Sure. So in this presentation, I'm going to discuss the 5 risk facts sourced from the Qualys Total Cloud Security Insights report from this year. And a subtopic, as you can see here, and here's a brief outline of my talk today. The promises of cloud. I'll go over the report methodology and the findings, and then I'll take a small deep dive into each of the top 5 cloud exploits and risk facts associated with those. And of course, at the end, I'll talk about recommendations that you and your organization can take to secure your cloud architectures. So first, the promise of cloud. So the cloud's been around for about 10 years, and we've been shifting, all our parts of our digital ecosystem to it. And there's been a lot of promises in terms of the cloud of the abilities, right? So scalability, elasticity, agility, redundability. That's a little joke. That's also predicated on what's called SRM, shared responsibility model. We've heard about these in different flavors from the major 3 cloud providers, but essentially the tech burdens are alleviated from the operators, and they're pushed down or to the cloud providers, the CSPs, and the consumer. We're allowed to focus on our core data applications, configuration of cloud services to make the applications and the data go the way we want. So as such, these core concepts promote the following benefits for the business. And at the end of the day, that's why IT and security exists. We're here to support the business and to accelerate them getting to reach their strategic goals as a company or an organization. So we're looking for cost benefits, and then also a shorter time frame to bring a product or service to market for consumers. And I have a little example about that shortly. And we also want to reduce friction in terms of adopting a new tech stack faster to see if it works in our environment. And now we see a lot of serverless, functionless, etc., and virtualization, obviously, that path. So in terms of bringing a product faster to market, a place I worked previously in the past 30 years, we're focused on beating a competitor, and we were using the cloud to scale up and scale down, trying new things. We were burning a lot of money and time and resources, but at the end of the day, we had a 3-year plan as a company, to get a certain product out before a competitor. And because of the cloud, even though we took kind of a hit short term on the OpEx cost of the cloud, we were able to bring that product faster. So, a little hit at first 2 years, but 3-4 years, we started to get that money back, and then we're able to slightly beat a competitor in terms of delivering that service for our customers. So it's a good way. But we all as cloud, and we have to be. There's still the same concepts remain. We still have to protect our assets from the threat actors. Let's move on. So the vulnerabilities described in this report are a result of 2 breakdowns, or the breakdown between 2 stakeholders: CSPs, the cloud service providers, and the consumers. Now, we both have an equal responsibility of deliverables to ensure successful use of the shared responsibility model. Now, from a methodology perspective, I'll go through these. This is how the Cloud Insights report was generated. So first, the data was pulled from our True Risk platform. And of course, it was anonymized for my privacy friends out there. None of the data can be traced back to a customer. We got the end-of-life, end-of-support detections from our cybersecurity, also known as CSAM product. And this may sound a bit elementary, but also in terms of the vuln detections are derived from the assets running in clouds, same concept for malware detections, and the remediation statistics are for the top vulnerabilities found in cloud environments. So I know we're talking about cloud, like why would he tell us this? I like to be very specific in terms, so we're all on the same page. I don't like to have any areas of ambiguity. So I'm very happy that the Qualys took the same path here. And of course, there's the CIS hardening benchmarks, data for the big 3, AWS, Azure, and GCP. There's a sneak peek at the top 5 cloud risk facts. I'm going to go over these in greater detail. But you will find the foremost risk to cloud security is the misconfiguration of cloud controls. And this can obviously expose sensitive data or resources to the public and lead to data breaches. And I'll talk more about this in the presentation. It can also lead towards faster enumeration recon from the threat adversary. They'll find data points out in buckets and etc. Maybe a device called a Juniper Notebook where they can use to extrapolate data and do some other things. I'll talk about that shortly. Now, the Total Cloud Security Insights report describes data-driven insights sourced from the Qualys TruRisk platform, like I said. And as a result, the details risks, the best practices associated with cloud computing. So here's the first one. The most critical issue is the cloud misconfiguration. Now, the cloud configuration, this means the control settings applied not just to the software, but also the hardware elements within the cloud fabric. And I have an example here, shortly we'll talk about that. Now, as you can see, the cloud misconfigurations are around the three major CSPs, AWS, Azure, and GCP. Now you can see here, Azure and Google Cloud are about the same, and AWS is a lot better in terms of the delta between the 34% to approximately 60%. Now, if I was in a live audience where I could interact with people, I would ask the question: is why do you folks here think that AWS has a lower fail rate against measuring against CIS benchmarks? And since it's kind of more of a rhetorical question, I will answer I always get some interesting answers, but AWS was the first, and typically sometimes the first ones to get to a tech stack, they'll do a really good job, but the people that get there second take the best and learn from their mistakes and optimize. So this was kind of interesting. AWS, one of the early folks of cloud consumer technologies, I know they've done a really good job in terms of iterating over their work to make sure things are getting better quicker. They also have a really good in terms of their documentation. So could go into more, but need to move on. Now, misconfigurations will definitely amplify the risk of data breaches and unauthorized access for many reasons. Complexity of cloud environments, lack of expertise keeping up with the evolving technology and features across these three cloud platforms. Of course, there's always our ever-present human error, and quick deployment of cloud services that either IT or security don't know about, and they're either not optimized or secured properly. And there's also the dynamic nature of cloud environments that also leads to this lack of visibility. So, for example, in summer of 2021, there was a cloud provider that was enabled a feature in a platform called a Juniper Notebook. And if you're not familiar with the Juniper Notebook, it's an open source tool that a lot of data scientists use to do what data science do, visualizations, number crunchings, etc. So what happened is the cloud provider accidentally turned on a feature, which led to the threat actor being able to do a privilege escalation within that cloud environment. And they exposed the database keys to over 3,000 customers. So the threat actor, like I said, did the privilege esc. After they did some recon enumeration, they found the keys inside the Juniper Notebook instance, and then they were able to list out the other notebooks in their region, and then that vuln allowed them to laterally move and jump to one notebook to another. So this is a good example in terms of, well, it's not a good example that happened, but in terms of what the cloud service provider could do. So if the underlying architecture, like I mentioned before, they turned on a feature, it led to this vulnerability. However, once they found out, the cloud provider was able to make that change, and the end consumer didn't have to do that. So that was kind of the good and the bad. Now, the bad is the cloud consumer who was using a Juniper Notebook, they weren't stolen, so they had to rotate their keys. So that's not so much happy days. If you've ever had to rotate keys, it's a very time-consuming process and very delicate in terms of all the pieces you have to step through. So, at the end of the day, the cloud consumer or the cloud provider, they fixed the underlying problem. But then us as the consumer, you had to list out and find out where if you're using Juniper Notebooks, what part of your regions, etc. And then you also had to find out where the keys are and then implement your process to rotate the keys. Dig a little bit deeper. So you can see in this slide, I have this broken out. Anything stand out to you? Let's focus on AWS. We have our friend here, the S3 bucket. We always know that's a problem. It's easy pickings. And then we found the config and CloudTrail. I find that a bit high. And then these are the percent of services failing, whether it's AWS, GCP, or Azure, against CIS benchmarks. That's the Center of Internet Security, in case we don't know. And so we see that the CloudTrail and config are quite high. And that's a bit alarming due to the fact that AWS config offers a more focused history of events that are based upon updates after resource configurations. It also keeps track of specific updates that are relevant to configurations. Now, CloudTrail, that looks at the majority of AWS AP activity. I suspect that part of the reason that's a little bit higher than normal is, there's a cost of using the service, and then you have to look at the data, right? But those are key things that folks need. Let's move on. Now, these are the three key misconfigurations across all the three cloud offerings. So first, we have encryption. Inside the report, it details out that within Azure, 99% of disks are either not encrypted or not using CMK, which is the customer managed key. And within all the CMKs, 85% of keys are not rotated. I'll get into a little bit more of that in a second. Now, the same level of risk affects GCP environments. We found just under 98% of the virtual machine disks for critical VMs lack encryption. So, a side note about rotation, I talked a little bit about it previously. What are your key questions to ask yourself about the key rotation? And how often should you rotate the keys? What is the process? Is it documented? Is it up to date? When's the last time the documentation was updated and tested? Has the testing process been executed by your primary and your backup personnel team? And have you documented the evidence of successful testing and process improvement? So these are all questions you need to ask in terms of key rotation, and not just to make sure that that operation can run smoothly, but also those are questions that your IT audit team can ask as well. They'll also want evidence like I did. A little pro tip. The second key misconfiguration factor, our good old friend, identity and access management. I know this is an obvious critical control. Now, we found that MFA in AWS is not enabled for 44% of the IAM users with console passwords. There is a tool, if you're not familiar with it, called IAM Access Analyzer. It's not enabled in 96% of the accounts scanned by Qualys. And just for a quick definition, the AWS IAM Access Analyzer helps you identify the resources in your account, such as Amazon S3 buckets or IAM roles that are shared with external items or entities. And lastly, external facing. As an example, 31% of the S3 buckets are publicly accessible. And as I noted a little bit before, these buckets are also not just exposing sensitive data, but they can also endanger other services in terms of accelerating that recon or enumeration phase of the cyber kill chain by the adversary. So to close out this slide, organizations need to explore ways and rely on automation to improve remediation, not just on-prem, but also in the cloud. As such, we highly recommend the work by the CIS, or Center for Internet Security, and its new process of mapping individual controls across its benchmarks to the MITRE ATT&CK tactics and techniques. And there's a good chart coming up that illustrates this shortly. I'm a big fan of fun facts, and here's a tech fun fact. Qualys contributed to the development of the CIS benchmarks for GCP, Azure, and AWS, respectively. Here's the chart I was mentioning before. So on the right here, we have the tactic and techniques from MITRE ATT&CK, and then the CIS benchmarks controls pass rate. To make it a little bit easier to read, we have these items in red under the techniques, and then where it's linked to the tactic that folks need to focus on. I'll talk a little bit more about resource hijacking in a little bit. You can also see that these pass rates for public facing are not that deep blue, so these definitely are need to be looked at and should be concerned, right? So on the left, we found that the tactics from hardening, like the prevent, the privilege escalation, initial access, and discovery, all trained 85% higher. That's really wonderful. But the attack chain, or the early stages, but in terms of the impact and the exfil, those really 4 to 14% passing the CIS benchmark. So that's a good place where you could start in terms of bolstering your defenses. Point 2, one of the most alarming discoveries was the number of cloud assets facing and exposed to the internet. So on the right, top to this, we found approximately 4% of cloud assets within more than 50 million scanned or externally facing. So 4% may not seem like a high number, but anything really over 0 is not good. And if you do the quick math, 4% of the we just found that 51%, in other words, 2 million of the 50 million assets are externally facing were unpatched. So 2 million externally facing assets were unpatched. So that makes for very easy targets for the adversary. Point 3 from the report, weaponized vulnerabilities give attackers a leg up in your cloud. So to illustrate this point, we have our good friend Log4Shell back in December of 2021. I'm sure we all knew about that. That was not the Christmas present we were looking for. So for a quick redo on that, Log4Shell was an externally facing vulnerability, became weaponized within 48 hours, being alerted. And we also found that obviously there's patches for Log4Shell, but it's still woefully under-remediated with a bit under 30% patched. And it's due to the complexity across the 3 major CSPs. And it takes about an average about 4.5 months to do that. And that's also, when you do the math there, you have about 70% of the items are still unpatched for Log4j that's externally facing. Moving on to point 4. Now, the data shows that the 2 greatest threats in cloud assets are crypto mining and malware. So the main damage caused by crypto mining is wasted cost of compute cycles, and also can be very expensive bills, especially if you're not planning on that. So there was a well-known use case in terms of a customer that got their AWS account hacked, and they were typically paying about $150 a month for the cloud services, and then they got hit with a surprise bill at $53,000 US dollars due to this illegal cryptocurrency mining. So it's a 350x increase in just 1 month. So either the cloud service provider or the consumer, someone's going to eat that or both, right? And there's only so many times that the cloud service provider may or may not help out with that. But when we take a look on the chart here on the right, we found that this malware here is this is the Denonia. Sorry, lost track of my place. So the top 3 categories of the malware in the cloud infrastructure are what's called Android Ghost, Denonia, and Scarlet Tail. I'm going to focus here on Denonia and finish up on Android Ghost and Scarlet Tail on the next slide. But the data shows the majority of the malware will impact insecure cloud assets in some form of a crypto miner, in this case, Denonia. And now on the left, you have the controls outside CIS benchmarks, and the 15 controls are passing rate just under 57%. And I'm sorry, yeah. And then the 7 of those controls are failing more than 50% of the time. This is within the AWS environment. Moving on to Android Ghost, remote code execution. So the data also showed in terms of Android Ghost and Scarlet Tail, Android Ghost works by targeting the .environmental files to gain access to sensitive info to get credentials. so they can move laterally across the network. So I have some peers that are in the pen testing world, and one of the things that they like to do is part of your enumeration attack techniques. They will find who are the system admins for the company, and then they get access to their laptop in various forms. And they search their file systems looking for these .env files because they know that an IT system admin or whatever may be working on a problem at 3 o'clock in the morning. They finish up the troubleshooting, they go to bed, and they may forget to clean up their machine. And that is easy pickings for the threat actor. And I also know, that's in the heat of the moment. We're all very good and security conscious, whether in the security field or not, or in IT. But you're up all 48 hours longer working on things. Sometimes those things fall. Now there's another one called Scarlet Tail, and this targets high-risk, externally facing cloud assets to gather credentials, and then specifically target Lambda functions. Now, for defenders, the challenge is the discovery and eradication of malware found, say, for example, Linux containers, which can evade detection for months. Now, traditional signature-based techniques cannot keep up with this advanced malware. So as such, a new approach is required, that deep learning AI. This approach is using different technologies that quickly discovers the advanced malware in the containers, and also by successfully analyzing network communications traffic between hosts and on the plane of the cloud. A good way to think about this, if we're in this conference like we are now, I'm speaking English, and all of a sudden Kelly starts speaking German. That's definitely something different, and something with some action would need to be taken. I know it's a simplistic example, but it helps illustrate the point. So that same thought, that deep learning plays a vital role, not just in detection that network communication traffic, if it's above or below the baseline, but also for sub-second detection of zero-day malware. And getting close to the end of the 5 risks, we have the threat data depicted, shown here in these charts. This clearly demonstrates the positive trend with automation in terms of automating remediation steps. Now, there's obviously some things that are a little bit more difficult to remediate, correcting misconfigurations in the cloud or replacing unsupported software. Really, it comes down to what is your risk tolerance for your organization and what are the risk factors that you need to mitigate. Obviously within security, it's about taking that risk-based approach and prioritizing that and working on those items that are most important for your organization to keep your business functioning. So for now, let's look to the right here. We have these 2 charts. And this is for non-Windows patches. The benefits are very clear when comparing the difference in an automated versus manual patch functions. There's almost an 8% difference in terms of the patch rate and a 2-day difference of time of remediation. So those are big deltas in terms of closing that window, closing that gap, making that target smaller for the adversary, making it more difficult for the threat actor to go after organizations, specifically in the cloud. So we have our old friend that never goes away. This would be tech debt. And yes, there is tech debt in the cloud. It's not just in terms of the technical stack. It's also to be thought of in terms of antiquated processes or approaches to using cloud resources in areas within the cloud that never got cleaned up, that should get cleaned up, or never got upgraded. It's the same concepts that plague us on-prem that plague us in the cloud. Now, what we found during this report, over 60 million apps were discovered to be end-of-life, end-of-sale software. And over the next 12 months, more than 35,000 applications will go end-of-sale. Now, a little sneak peek, I am actually working on a new presentation that I'll be doing in 2024 about a use case a place I worked previously where I used tech debt as a catalyst to reduce the attack surface by partnering with IT, and we're able to drive down the attack surface immensely, taking this risk-based approach on this more antiquated approaches and systems, and also get rid of some IT stacks that were been plaguing, some older items have been plaguing IT for a very long time that need to go away. But what I like about this chart here we have our detection count, and then this is by the year. And this is the count of detections of end-of-life and sale software, but by when it goes end-of-life into sale. So some interesting ones. In 2021, we had 3.5 million end-of-life into sale, and the year previous was about the same. So when this report was cut about halfway through the year, that's why it's like that, in case you're wondering. Let's move on. So closing things out here, you can see that the Total Cloud Report provides insights that enables organizations using cloud tech to better understand these risks and how they can be better prepared to face those challenges by today's ever-changing threat landscape. So I'll leave you with these recommendations. The first recommendation is leverage the security configuration benchmarks. CIS is always a good place to start to consistently detect and remediate cloud configuration drift. So when I was working someplace else, we were adopting the cloud, and just to help myself and my team get around the concept of cloud, I said, look, let's just think about it in terms of like an IDS configuration change. Like something changes, we have to do, or a FIM. Something changes, something happens. So it's just one approach to take to it. Talked about this in the past, but using a risk-based or a risk of exploitation to prioritize patching or IS workloads, that's very important. You want to look past traditional mechanisms in terms of signature-based detection of your malware. You definitely need deep learning, AI to take care of this, and baseline of your environment is how you do that. You need to leverage automation in terms of remediation and connecting into existing workflows. If you have a ticketing system that's already there, make sure you can work in that. Don't recreate the wheel, right? I've seen people do that in different companies, especially when I was in consulting, that they would write a whole new stack. I was like, why don't you just connect into the existing ticketing system? That's what you need to do. And to help reduce the spread of the threat actors and their opportunities, we need to protect administration interfaces from the internet by leveraging zero trust principles. So one way to think about this is, we have two use cases. Back in October, the Cisco iOS web UI interface was attacked. The adversary was able to go in through the web UI, create a local user account, privilege escalation, and then place the malicious files on Cisco file system. Before I went to security, I was a network engineer for 10 years. I never thought that could happen. Now I am. Now we see it. An example that we all most likely know, in May of this year, there was a flaw in the MoveIt, the transfer web app. And that starts off with our old friend SQL injection. That person never goes away, unfortunately. And it went to remote code execution. And the attacker executed an unauthorized transfer through a custom web shell known as LimaLoot. And using LimaLoot, the attacker can steal other data points and items with the Azure Storage Blob, associated with the Azure Storage Blob and information tied to that. So using MFA in turn, if you have to have those administrative interfaces or facing to the internet, definitely turn on MFA for that. And I would turn in advanced logging. And I would constantly assess the risk profile of those, because those things can change, right? Whether it's those more traditional, what we're used to, Cisco iOS or maybe a transfer web file, or you have some externally facing items that are cloud, right? You have to continually assess that. So I'm going to leave you with these two QR codes. One will take you to the Qualys Total Cloud Security Insights report. I highly encourage you to download it and read it. There's a lot of fun facts and a lot of things that can help you in terms of bolstering your cloud security posture. And that's my LinkedIn contact info if you want to get in touch with me. Now, I know I'm talking to a bunch of security professionals, and you may be a bit weary to do the QR codes. I'm not going to rickroll you. However, if you don't want to do the QR codes, you have my email, jhankins@qualys.com, and you can ask me a question, and then I will also get you in contact with your local, geo-regional specific sales team so they can answer those for you as well. I thank you for your time and attention. I thank Kaylee for inviting me to come to this, and this has been a lot of fun for me.
Again, thank you so much, Josh. And again, thank you for getting up so early to give this talk to us. We're going to have to move on quickly, but I've got a couple of questions, if I may, from the audience to put to you just before we move on.
Sure, I'm happy to answer.
Can you provide any examples of real-world attackers and how they've exploited cloud misconfigurations, similar to the Capital One incident, and what lessons did we learn from it?
Oh, I knew somebody asked me that. And now it's 4:30 in the morning.
I'd like to keep you on your toes.
Yeah, no, I get it. That Juniper notebook is a place I worked previously. That was something that we found. I know if you look at that, it affected some really super high profile customers. If you Google it, it's through Azure Juniper Notebook, and the customers affected are very, very high level, are very, very well known. So that one's a more interesting one because it's not such. To me, it reminds me of what was called the old vuln chaining back in the day. You stack vulns, and then you're able to get in what you need. And that one was a little bit different in terms of you had to have that specific notebook, which was very specific for data scientists. They did very specific things, and it had to be in your region. And they found that the threat actor did just by that misconfiguration by the cloud provider, which they were trying to do something good by optimizing the notebook for their customers, but it led to that. So that would be in terms, you're not going to know like, hey, that feature got turned on. Is that good or bad for me? Did it optimize the kernel? Whatever, I don't know. But from a detective, corrective, and protective, or detective, corrective, and protective controls, you can always do that where you have like all knowledge of what's going on in the underpinning of the cloud. So you could ratchet up your monitoring, that things of that nature. And I also do some things when I was managing defense team. I did my own canaries and also helped. So we can talk more about that later.
Thank you. And then just one final question before we move on. In the context of IAM misconfigurations, how do you recommend organizations balance the need for robust security with the need for accessibility and ease of use?
Oh, that favorite question. I love that one. How's this going to play out in the user world? That's fine. So I think one way to do that is when I was faced with problems, I hope I can say it a little bit better with these fun problems at other places I've worked. I would wrap it around what detective, preventive, and corrective controls. There, I said it right that time. We wrap around this problem. And before, one thing that's always our last resort in this field is let's get a risk exception, make sure it's timed. It's not a get out of jail free card. That is like the ultimate last straw. Of course, the business owner and the IT folks have to sign off on that. I would advise having different accounts if you can, tied to certain functions. I know it's kind of a high-end question, but if you have different accounts that are checked out at different times, or if you have higher accounts or privileged accounts with higher access, they can be checked out different times, and you have extra logging around that. Now that that's not available, then you're going to have to do something in terms of more like a temporal. Hey, this is only for this amount of time, or you have to do it programmatically. It makes it like an API call. It's like say like a password vault of some sort, and then that's logged. Of course, everyone would assume that, but I like to state the obvious because sometimes what the obvious isn't always obvious. That's logged and it's timed, and then you review those logs. But I would review that in terms of baselining and is it normal? Does Kaylee always check out this account Monday at 8 a.m.? Yes. And all of a sudden now it's Sunday at 7. Is it Kaylee or somebody impersonating Kaylee doing this? Mm-hmm. And then this last step seems elementary, but I think a lot of people don't do it. So in terms, because it's so elementary, but it's so powerful, it's testing your controls. So if I would write, not me, my team would write a SIM log or have a log. So then go to my SIM, I would do testing to make sure it works as designed. Did it fire as designed? And I would test that too, because those are questions not just IT audit, but my upper management board directors ask. They wouldn't ask it like that. They would say something like, did you test it? Many would say it like that. But you'd be surprised, just those little things in terms of actually up the detective controls and testing it. And periodically, don't test it once, like it's all done. Because in the case of the Juniper notebook, like it's not exactly the same. Like they made a change and now it doesn't work. Well, what happened? So hope I answered the person's questions. I'm happy to do it more later.
Yeah, if we sometimes we do get some after the sessions because we send out each session to our audience. So if we do, we'll forward them on. But thank you so much once again, Josh, for that session.